Now, hyperparameter tuning, as we said, after you do model selection, after you minimize or shortlist the number of models, you may look into training or adjusting the values for the hyperparameters the model has. Okay, for example, if you're talking about KNN, so we have hyperparameter called K. K is the number of neighbors. So as when you start, you may just keep it as default value, but later you may need to adjust. You have another one we talked about is ridge regression, ridge and lasso, right? They have what's called alpha value. Alpha value. So this is hyperparameter. If you're talking about deep neural network, so you have the number of layers, you have number of neurons, the learning rate, all of these are hyperparameter. You need to adjust. Okay, you need to adjust in order to have the model in the best shape. Okay, in the best shape. Like you have the radio, the old radio, and then you adjust the knob in order to have the sound of the radio channel so clear in the best way. So here, hyper tuning is like this. You are adjusting the knob to have clear voice on your radio. Okay. The choice of hyperparameters. So now how we can decide whether to go, let's say, with number of layers 3 or number of layers 5. Again, we evaluate using the validation set. We use the validation set to evaluate. So here you see you got score. This is using validation set, huh? So you see how validation set is good. Now, do you need to do this process for hyper tuning by yourself, where you have for loop and you start maybe adding a list of hyperparameter you want to tune and so on? Luckily, you don't need to do any of these. So already scikit-learn has 2 classes that you can use for hyper tuning. You have grid search CV and you have randomized search. Okay, let's take a look what they are. We already explained during practical, but let's now look. So it performs exhaustive searching. Now we say why it's exhaustive, or unless if someone like to enlighten us why they say exhaustive, through a specified hyperparameter space. This is simply, we call it the searching space. Like your bag or your collection where you put the hyperparameter with their different variation of their values and you'd like to find the best combination. Okay? Evaluating all possible combination. Evaluating all possible. If you like to highlight the word all possible combination of hyperparameters. This is why it's called exhaustive. Okay? Clear? This is why it's called exhaustive search, because it's going to leave no combination aside. So it's going to consider all different combinations that you can get. This is why it's going to perform exhaustive search. Okay? Like I give you, I'm looking for something, and then I give you a searching space inside the room you need to find. Okay? Then you go and leave no stone unturned, as they say in English. You look everywhere, okay, for every possible combination. Maybe I'm asking you to adjust the room to look nice. So you look for every combination possible. You do, then you check which one is best. Okay, so we call it exhaustive search. How to use? Very simple. You import grid search CV. Then here, this is your searching space. Searching space, this one. Okay, so here, for example, we're looking for number of estimators. We're looking for max features. This is one set. You see, even you can have different sets, not only one set. So here we have one set of combination we are interested. This is one set. Here we have a second set. So meaning you have many choices to go through. So maybe earlier I was just looking for one set without bootstrap. Bootstrap maybe by default is true. Okay, later we talk about bootstrapping. And then for second set, I'm considering now if the case bootstrap is false. Okay. And notice for false, maybe I'm looking for different searching space. So I'm looking only for number of estimators 3 and 10, and max features maybe 2, 3, 4. Okay, and so on. Then we use, okay, here this is, so here we have random forest, our algorithm. We just create an object. We don't train. You don't train because grid search CV is going to train for you. Okay, is going to train. So you don't train, just you create an object, and then you pass your grid search CV. Of course, if you are using pipeline, then same thing. You pass your pipeline here. Here, you pass your pipeline. Okay, if you are using pipeline, which is recommended, then you pass here your pipeline. But just for simplicity, we're showing here, just imagine we have algorithm and we want to hypertune it. Then what you need to do, you need to provide the searching space and CV value, because grid search CV also apply the concept of cross-validation. Same thing, same cross-validation concept we discussed earlier is going to be used by grid search CV. Meaning, in order to find the best combination, each combination is going to be tested how many times? 5 different times, each combination. What do we mean by each combination? Let's say we started with set 1. So first combination would be, let's say number of estimator equal 3 and max features equal 2, right? So suppose grid search CV following cross-validation is going to partition the training data set into 5 partitions, 1 partition for validation, the remaining for training. So how many times is going to train using this configuration, if you like to name it? 5 times. So let's say here we have random forest, RF1, RF2, RF3, and so on. And each one is going to give you a score. Okay, and so on. And then eventually you can take the mean. So let's say mean 1. Then what do? You go with the second combination. So let's say number of estimator this time is 10. Max features is 2. And then you repeat the same process. And you will get, let's say, me2 for mean value, the score value for second combination. So it's going to actually spend long time and doing cross-validation concept, because again, we need to have authentic. We're looking for reliable results. So again, one assessment is not enough for one combination. So this is why we are doing multiple assessments for each combination. So if you like to count, considering only, forget about set 2, assume it's not there, then how many random forest grid search CV in total is going to create? How many random forest grid search CV in total going to create? Okay, so here, how many combination? For number of estimators, we have 3 variation, multiply by 4, right? Equal 12, multiplied by 5. Because CV, remember, for each also portion, you are going to build another tree. So total, how much you get? So 10 by 5, 50, 60. 60 random forest grid search CV is going to train for you. Otherwise, if you don't have it, then you need to have 4 loops, nested 4 loop, starting from first combination, going with cross-validation, second loop, and so on. So grid search CV is going to do it for you. Okay? So far, so bad? Right? We're looking to have bad understanding, right? If I'm doing good, tell me so I can reduce my explanation. Another class you can use, you have randomized search. Randomized search, unlike grid search CV, it doesn't apply exhaustive searching to every combination you have. But actually it may, if you like, it may do more than grid search CV. Okay, anyway, so it evaluates the given number of random. So since the word random, so that means it's going to create random combination. So just you need to provide ranges for the values that each hyperparameter can have. And then randomized search is going to create random combinations, okay? Following your ranges, of course, but randomly is going to create them and then apply cross-validation and so on and so forth. Same like grid search CV, but except grid search CV you need to provide every possible value you think you would like to test your model for. In randomized search, you give ranges. Let's see an example. So back to the same example, we are training a model, but this time using support vector machine. It doesn't matter which algorithm. So you need still to provide the searching space. Okay, but this time you don't provide the exact value, just you provide ranges. Just you provide ranges of the possible values that your model can have for its hyperparameters. Then you create an object from randomized search. You pass your model, the searching space, the CV, same, because it applies cross-validation, same concept. Plus, you need to provide the number of iterations, because simply randomized search is going to create random combinations. But how many combinations you are interested with randomized search to create for you? So you need to specify by the number of iterations. Do you need to specify the number of iteration grid search? No, and you don't have such, because anyway grid search CV is going to go doing exhaustive search. It's going to look for each and every combination. Okay, clear? Okay, again, why we have random state? You see, whenever you see there's randomization inside your class or your function, there's random state to ensure the results are reproducible. Otherwise, if every time you run a random, complete random, then every time you get different results. So you don't know what's going on, all right? Like you are adjusting the radio loop, and then sometimes you go right, you see increment happens better, the quality, sometimes no, the opposite becomes. So if there's no fix for the output, the way you produce the output, then you're going to be lost. You don't know what's going on. Maybe you remove the antenna, and then you see the results become better. Other time you remove the antenna, becomes worse. So the output is not reproducible. So we need to ensure the output is reproducible. Of course, there's no antenna here, just I'm talking about radio. Huh? Okay. And then random search dot fit. So when random search called fit is going to train the model. This is why, again, when we created an object of SVC, we don't train. Just we create an object and pass it to grid search CV.